Okay, college algebra. As we begin graphing polynomials and working with polynomials in this unit, you may not have this sheet, but don't worry. If you want to print it off, I do have it online. But if you kind of draw some of these general graphs, you'll get the idea. You don't necessarily have to fill it all out. I don't think it'll necessarily happen that much. But we want to talk about general shapes, and these aren't all the equations, but there's some. So like y equals x, and you can have some stuff after that. Second degree y equals x squared, y is equal to x cubed, y is equal to x to the fourth, y is equal to x to the fifth. And, these can have all sorts of then, pieces added on after, plus 4x squared minus 2x, so on and so forth, things like that. But we're just going to talk about the leading degree being x to, second, third, fourth, fifth, anything like that. So the general shape is, x is a line. X squared is a parabola. X cubed is kind of this kind of shape. And x to the fourth is this kind of shape. And x to the fifth is this kind of shape. And what you notice is that as you draw these, you kind of add a bump in as the as the degree changes. So these are called extreme values. So this is an extreme value. These are extreme. These are extreme. These are extreme. If you notice, a fifth degree polynomial has 4 extreme values. A fourth degree has 3, a third degree has 2, a second degree has 1, and a first degree has none. So given a polynomial of degree n, there are most n minus 1 extrema. So extrema is a word that we use for these maximums and minimum spots. Okay. And part of what I want to talk about is the degree here. So the degree of the polynomial. And let's start by looking at the odd polynomial. So odd, odd, and odd, because we have first degree, third degree, and fifth degree. And we write it like this. The limit as x tends towards infinity is equal to, that kind of language says, as x goes this way, what happens to y? As x goes this way, what happens to y? As x goes this way, what happens to y? Well, in all these cases, the y value goes to infinity. I'm sorry, I'm putting in the column of negative infinity. So the limit as x goes to infinity is infinity. And the idea is if you take a large positive number, so we'll focus on x to the fifth right now. If you were to take a large positive number, say like 100, and you were to take it to the fifth power, you would get a large positive number. But consider the limit as x goes towards negative infinity. As you head off to the left, look what happens to the y values. As you head off to the left, look what happens to the y values. Again, to the left, look what happens to the y values. They go down. And so we say the limit as x goes towards negative infinity is negative infinity if n is odd. Now, why is that? Well, consider cubic. If you take a large negative number, say negative 100, and you raise it to the third power, you're going to get a negative result. That's why that works that way. Okay? Now let's look at the even examples. Notice that for x squared, as you head to the right, the values go up, and as you head to the left, the values go up. Same thing for a fourth degree. As you head to the right, the values go up. As you head to the left, the values go up. Why? Because if you take a positive number, like 100, and square it, you're going to get a positive value. And if you take a negative value, like negative 100, to raise it to the fourth power, you're again going to get a positive value. So if n is even, the limit as x goes towards negative infinity is positive infinity. And the limit as x goes towards positive infinity is again infinity. That's what happens. I'm going to erase some of this. Get just a little bit different idea. Get We have our first degree, second degree, third degree, whoop, fourth degree, and fifth degree. So right now, I don't want to focus so much on thinking about what happens as x goes to positive infinity or negative infinity. I want to look at what happens if the front coefficient is negative. And I think we know that these are going to flip upside down. So that's if we're negative. So all the black are positive and all the red are negative. And I want you to look at some interesting things here. Here's the first thing we can say. If it's positive, it ends positive. If it's positive, it ends positive all the time. If it's negative, it ends negative all the time. If they're odd, they start and begin in opposite places. If they're odd, you can see they start and begin in opposite places. Whereas if they're even, they start and end in the same places. And that's something that's really important to keep in mind. So, as we end here, there's something else that we want to be able to look at, and that is that sometimes we have single roots. For example, suppose you had x is equal to 2. That's a single root, say x minus 2. And the graph simply just passes through the x-axis at one spot. But suppose you had a double root, like x minus 1 times x minus 1. That's what we call a double root. And what happens in that situation is it comes down and touches. So a single root would look like this guy right here at 4. A double root would be what's happening at 1. A triple root, say x minus 2 times x minus 2 times x minus 2. Well, in that situation for a polynomial, you'll end up with this type of behavior. Well, try that again. Kind of looks like a cubic. And that would be an example of this right here. This would be a triple root, this would be a single root, this would be a double root. And so this kind of polynomial right there, we can actually tell a lot about it. And this is kind of a good thing to wrap up before we begin, kind of some of the problems in your notes. First of all, it starts down and finishes up, so I know it's positive, and I know it's going to be odd because it starts and ends in opposite directions. I have a triple root there. I have a double root there, a single root, and a triple root. Well, if there's a triple root and a double root and a single root and a triple root, I know this is actually x to the 9th degree polynomial. So there's a lot that you can tell about it. In fact, one last thing here. It's just fun to look at. It looks like it goes through -2 with a triple root. So I can write x plus 2 to the 3rd power. And then it goes through 1, x minus 1 raised to the 2nd power. And then it's going to go through x minus, or x, it's going to go through 4. So I write x minus 4. And then it's going to go through positive 7. So x minus 7, it looks like a triple root. So I'm going to raise that to the 3rd power. And if you look at your window here, say, look at my window, looks like I go all the way down to -50,000, all the way up to 40. My x min is -4, but my x max is 8. Tick marks every 2. My y min, we said, is -50,000. And my y max is 40,000. And I got tick marks every 10,000, it looks like. So if I put that same data in and I press graph, notice what I get. Get the exact same picture that's there. I came up with the the equation on my own just by looking at it. There it sits. And you're going to be able to do that pretty easily after we go over stuff for today. So we flipped your actual notes, and here we go. Well, a sketch of the graph of the polynomial. It's already in factored form. And what I like to do is I like to think of whether it's positive or negative, and where it starts and where it ends and where its roots are. So you see you have x times x. This would be an x squared. And it would be a positive x squared. Because it's positive, it will end up. And because it is even, it will start and end in the same directions. So as I graph this, I just have to plot positive 2 because that's one solution, and negative 3 for another solution, and I draw the graph right through. There's a quick sketch of your graph. If you were to multiply this all out, you get a negative x cubed. Because it's negative, it will end down, and because it's odd, it starts and ends in the opposite direction. I have solutions of negative 4, positive 1, and negative 5. So I mark negative 4, negative 5, and positive 1. Notice it starts up, as we said, and ends down. So there's my graph. This next one is an x cubed, and it's positive. Because it's positive, it ends up. Because it's odd, it starts and ends in opposite directions. It has solutions of 0, 1, and negative 5. Starts down, finishes up. This one will be a negative x cubed when you multiply it all out. Because it's negative, it will end down. Because it's odd, it starts and ends in opposite directions. Looks like negative 4 is a solution, and this time it's a double root. So it's going to cross at negative 4 is a double root, and it will cross also at 0. So the double root means it just bounces off like a parabola and heads down. That's the type of action that you want to show. When you multiply these out, because this x is negative, you're going to get a negative x to the 4th. Which means because it's negative, it ends down. Because it's even, it starts and ends in the same direction. So I mark it out, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All are single roots. In this situation, you multiply it out, you're going to get positive x to the 5th. Because it's positive, it will end up. Because it's odd, it will start and end in opposite directions. Notice you have a triple root of 0, and you have a double root of 4. Mark 4 and mark 0. Triple root there. So triple root is going to have to look like that. And then double root like that. The next one, we have a minus x. When we multiply this out, we'll get a negative x to the 4th, which means it ends down. Because it's even, it starts and ends in the opposite directions. 5, negative 1, and negative 1, double root there, and positive 2. So negative 1, 1, 2, 3, 4, 5. So I mark 5, I mark 2, mark negative 1. Bounces off because it's a double root, passes through, passes through. The next one, when you multiply it out, you're going to get negative x to the 5th. It's negative, so it's going to end down. And because it's odd, it will start and end in opposite directions. Go ahead and mark. We have 0 and negative 2 and positive 4. Notice a triple root at 0. pass through, triple root, pass through at 4. A lot of examples here. I usually have students trying to do a few on their own at this point. I'll do a couple more with you, but if you want to pause and try some on your own and see how than I do, you sure can. Multiplying this out at negative x cubed, it ends down because it's negative, because it's odd. Oh, sorry, that's not negative x cubed, it's negative x squared. Just a negative x squared. So because it's negative, it ends down, it starts and ends the opposite or same direction because it's even. Going to go ahead and mark negative 4. And 3. That's my shape. This one's going to be an x to the 4th, positive. It's going to end up because it's positive, start and end in the same direction. I mark 5, mark negative 3, 5 and negative 3. Looks like a double root in each situation. Double root for each one is going to look like this. There we have it. The next one, x cubed, it's positive. So it's going to end up, starts and ends in opposite directions. As you're watching, you may wonder why I have so many examples. It's because people have needed them in the past. Like I said, I usually have students that try some on their own. If you're not doing that, again, you might want to try it and then check to see how you're coming out. Because some people, this comes very naturally to them. Other people, it's a situation where they really struggle to think about how the graph goes, especially when you get double roots and triple roots. We have to go over that, and then let me know. We'll practice in class. That's a negative x cubed, so it's going to end down. It'll start and end in opposite directions because it's odd. Want any double roots? They're all single roots, so I just plot. Whoop, it's negative. Again, it's messed up. Again, there you have it. Do a few more here. This could be a negative x to the 4th. Because it's negative, it ends down. It starts and ends in the same direction because it's even. 1, 2, 3, 4, and 0. A triple root at 0. So we're going to do this triple root thing, and then a single root at 4. Next one, if you multiply it out, you get a positive x to the 4th. It's going to end up. It's going to start up. Looks like I have 2 double roots at negative 5. Multiply the next one out, you get a positive x cubed. It will end up. It will start and end in opposite directions. It's going to have a double root at 4. A single root at negative 1. There we go. This one, x squared, x cubed, x to the 4th, x to the 5th, because it's squared there, so positive x to the 5th. Going to end up, because it's positive, start down because it is odd, so it starts and ends in opposite directions. Plot 5. That's a double root. Plot 1. Plot 0. Plot negative 3. Sometimes maybe you want to put a special mark where you have a double root so you remember what to do. So I'll put a green mark there. I don't know, whatever helps you guys. There's a good example of a fifth degree equation looking that way. And our last two, multiply these all, you're going to get positive x to the fifth. It will end up because it's positive, and it will start and end in opposite directions. Go ahead and mark it out. You have 0, and then you have 1, 2, 3, 4. So if you mark off your 0 and you mark off -4, looks like we have a double root. So there's my double root, and then there's my triple root. Multiply these, you get a negative x cubed. It will end down because it's negative, start up because it's odd. They start and end in opposite directions. Go ahead and mark it out, 0, -1, and +4. There we have it. All right, folks, lots of examples. You should be ready to practice now. In your work, you're also going to be asked to factor in some situations. So go ahead and if they're not factored, factor them so you can figure out the graph. We'll see you soon.